Okay, so for question 6, I'm dealing with a cone and a cylinder, so I need to get the volume of a cone and I also need to get the volume of a cylinder. So first of all, I'm going to get the volume of the cylinder. So formula for volume of a cylinder is pi r squared h. So pi bracket, my radius is 4 to be squared, my height is 8. So the volume of the cylinder is 128 pi. Then I get the volume of my cone, which is 1/3 pi r squared h. So I have 1/3 pi, my radius is 4, my height is 3, and my answer is 16 pi. Then I need to get my slant height here. Okay, so I have a squared plus b squared is equal to c to b squared. So I have x squared plus 4 squared is equal to 5 squared. X squared plus 16 is equal to 25. I get x squared is equal to 25, take 16. And I get that x squared is equal to 9, and I get x is equal to 3. My total here then for my volume is 128 pi plus my 16 pi. Okay, so earlier there I did not actually have my height, so that's why I had to go off and get my height of that particular cone to fill into my formula 1/3 pi r squared h. Question 7 then I have here is volume is equal to pi r squared h, so v is equal to pi bracket 15 to be squared bracket 50, and that's equal to 11,250 pi centimeters cubed. For part 2, I was asked to calculate the volume of the cone. Give your answer in terms of pi. Formula for the volume of a cone is 1/3 pi r squared h. So I have volume is equal to 1/3 pi 15 to be squared. My height is 45, so I get my volume to be equal to 3,375 pi centimeters cubed. Then part 3 of this question asks what fraction of the cylinder remains after the cone is removed. Okay, so what I'm left with then, okay, is 3,375 over the total, which is 11,250, which is equal to 3/10. The fraction remaining then is that's how much the cone actually occupies. Fraction remaining is 7/10. Someone else might have taken this figure from this and put it over my total to get 7/10 as well. Both methods are correct. The next part then, part B, says to calculate the three significant figures, the surface area of the remaining solid. Okay, so what I have is I have the top of the cylinder plus the curved surface area of the cylinder plus the curved surface area of the cone. So I have pi r squared plus 2 pi r h plus pi r l. Okay, I need to get my slant height, so I have a squared plus b squared is equal to c to b squared. My height is 45. My radius is 15, and I'm just working out here, so I have 45 to be squared plus 15 to be squared is equal to x squared. I have 2025 plus 225 is equal to x squared. 2250 is equal to x squared. I get x then is equal to 15√10. Filling into my formula, so pi r squared for the circle, 3.14 bracket 15 to be squared, plus then I have my curved surface area of my cylinder, which is 2 pi r, which is 15, and my height is 50. Then I have plus 3.14 my r, which is 15, and my l, which we just found out, is 15√10. And then when I work all of that out, I get 7,650 centimeters cubed. Okay, so now I'm going to go on and explain spheres. So these are found in your log tables as well, these formulas. So I have the volume of the sphere is 4/3 pi r cubed. The surface area of a sphere is 4 pi r squared. I only have the curved surface area of a sphere because obviously it's a round shape. I can't have a total surface area which will include a circle because there's not going to be a circle other than the total surface area. Volume of a hemisphere, so half a sphere, is 2/3 pi r cubed. The curved surface area is 2 pi r squared. That's the round part, but remember I'm going to have a circle on the top of a hemisphere, so the total surface area of a hemisphere is the curved surface area plus a circle. The area of a circle is pi r squared, so the total surface area of a sphere is 3 pi r squared. Then I'm going to run through two examples here. So the first example says find the volume and surface area of the sphere shown below in terms of pi. So the volume is equal to 4 over 3 pi r cubed. Volume then is equal to 4 over 3 pi. My radius in this case was 6 to be cubed. Volume is equal to 288 pi centimeters cubed. Surface area then is equal to 4 pi r squared, and I have 4 pi bracket 6 to be squared, and I get my answer to be 144 pi centimeters squared. And then here I have find the curved surface area and the total surface area of a hemisphere of a radius 10 centimeters. Pi is equal to 3.14. Curved surface area of a hemisphere is 2 pi r squared, so I have 2 bracket 3.14 bracket 10 to be squared, which is 628 centimeters squared. My total surface area of a hemisphere is the curved surface area plus the circle, which is pi r squared, so my total is 3 pi r squared. I have 3 bracket 3.14 bracket 10 to be squared, and I get my answer for this one to be 942 centimeters squared.